Okay, today in pre-algebra we're talking about simplifying algebraic expressions. This is chapter 4, lesson 2. Okay, so up at the top here, I'm going to kind of skip the top part here and come right here to the first concept, parts of an algebraic expression. So it says when addition or subtraction signs separate an algebraic expression into parts, each part is a term. Okay, remember that's when addition or subtraction signs are separating those different parts of that algebraic expression, okay? It says the numerical part of a term that contains a variable is called the coefficient of the variable. So let's start with the terms that we have. You can see we've got an addition sign, 3 addition signs here, and those addition signs are separating these 4 parts of this algebraic expression. So here we can see that this expression has 4 terms, okay? Then that numerical part of the term that contains the variable, so here if I took out 3x, I would look at this term and say, okay, here's my variable and here's the numerical part of my term, okay? This 3 then here is the coefficient, okay, of x. If you had something that looked like 4xy, again, you would look directly before that variable and then again here, 4 is your coefficient, okay? All right, taking a look down here, it says in this chapter we will work only with terms with an exponent of 1. In this case, like terms are terms that contain the same variables, such as 2n and 5n, or 6xy and 4xy, okay? It says a term without a variable is called a constant. So I know that yesterday doing distributive property, we needed to have some kind of basis of what a like term is. So just understand that in this expression right here at the bottom, 5y and 2y are like terms. If you're ever unsure of whether something is a like term or not, I would say 2x and then I added 3x to that. You are always going to look at the variables directly after that coefficient. And if they match identically, then they are like terms. So in this case, 2x and 3x are like terms, and I can add 2x's to 3x's, which gives me 5 total x's. Down here, if I drew another one and I said 2xy plus 2x, once again, make sure you're looking directly after that coefficient, and everything directly after there has to match identically. Here you have an xy, and in the second term you have just an x. So they are not like terms. So if I were writing an answer, just like you did with distributive property yesterday, I would say 2xy plus 2x, and that would be my final answer because you don't have a number that you can substitute in for either one of those variables. Okay, let's take a look at example A. I'm just going to go ahead and rewrite it down here. I have 3x plus 4y plus 4x. And the directions ask me to identify all of the like terms in these expressions. So once again, take a look directly after that coefficient, and whichever terms match directly after that coefficient are our like terms. So here I've got an x, and over here on the right I have an x, and those two, 3x and 4x, are like terms. Now because I have nothing that matches my 4y or my y right here, I know that 4y is an unlike term to both the 3x and the 4x. Coming down here to b, b is 5x plus 3 plus 7x plus 4. Okay? Once again, highlight, circle, underline everything directly after that coefficient. And here you can see that our x's right here, this one and this one, match identically. So I know that 5x and 7x, those two are like terms. And then I'm going to come here and say, hey, I have nothing after this 3 and I have nothing after this 4. Those two numbers are constants. And since they technically match and there is nothing after them, 3 and 4 are considered like terms. All right, moving on to the next slide. It says rewriting a subtraction expression using addition will help you identify the terms of an expression. So all they want you to do, remember, if I look at this expression they give me right here, I can rewrite that into an addition problem. So it gives me 6x plus, and remember we're always isolating our negative rational numbers or negative terms, in this case, in parentheses, plus a negative 2y plus x plus a negative 5, okay? So in the directions, it asks me to find the terms, which I'm just going to identify by a T, like terms, which I'm going to put LT, coefficients, I'm going to have CE, and our constants, which is just a C, okay? All right, so let's start with the first one, our terms. Remember, a term is any number or any part of that expression that's separated by addition or subtraction. So you could come here to this first original problem and say, hey, I've got 2 subtraction symbols and addition symbol, so I know that 1, 2, 3, 4 terms are being separated. In this case down here, just understand that I actually changed everything to addition, but it still gives me 4 total terms. I have 6x, negative 2y, x, and negative 5. So it still leaves me with 4 total terms. Now, if I find the like terms, remember like terms are anything after that coefficient that matches. So I have an x, I have a y, I have an x, and I have nothing, okay? In front of this x right here, when we have a variable that is just by itself, understand that that is a coefficient of 1, okay? So really, I have a 1 right here. That is the coefficient to my x. We just don't write it that way because 1x is the same thing as just x. Okay, so identifying those like terms then. This x matches this x, so I would go ahead and write 6x and 1x, or just x. And here you can see that my y and my nothing do not match. So those are the only pair of like terms that I have in this expression. The next thing we're going to do is identify all of the coefficients. So here directly in front of this variable I have a 6. Directly in front of this one I have a negative 2. Remember that an x has a coefficient of 1. And because this problem or this part of the expression right there does not contain a variable, we know that there is no coefficient there. So my 3 coefficients are 6, negative 2, and 1. All right, and then the last part is to take a look at what my constant is. Well, because this is the only term in the sequence that does not contain a variable, I know that a negative 5, is always going to be a negative 5, okay? And when I say that it's always going to be a negative 5, take a look. If I had 2a, and if I told you that a equals 2, what would this really mean then? It would mean that 2 times 2 is really equaling 4. But if I had just a 2 with nothing else there, a 2 is always going to stay a 2. In this case, my 2 didn't stay a 2 because I have 2 multiplied by a, and I told you that a was 2. All right, let's take a look at the next slide here. It says an algebraic expression is in simplest form if it has no like terms and no parentheses. When you use distributive property to combine like terms, you are simplifying that expression. So here in A, it says 4x plus 6 plus 2x. Okay, remember we're identifying all like terms first, everything directly after that coefficient. Remember here I have a nothing, so I can see right now that this x and this x match, and I know that 4 x's plus 2 more x's gives me 6 total x's, and I'm adding 6. Because these two are not like terms, I cannot combine them any further. Taking a look down here at B, we have 5n plus 2 minus n minus 6. Now you can look at this problem and rewrite it just like we did on the last slide as an all addition problem. Or you can say that, hey, this symbol that's directly in front of my n actually sticks with my n. So it's really a negative 1. Remember there's a coefficient of 1 there. It's really a negative 1n, okay? Or likewise, this 6 carries that subtraction symbol directly in front of it. So it's actually a negative 6. All right, so first let's combine our like terms, okay? We have an n here and an n here, and we also have nothing here and nothing here. So I know that my 5n and my 1n can be combined, and you might want to rewrite this like 5n minus 1n And then remember that symbol sticks directly in front of it. So I have a +2 and a -6. Well, let's split this into 2 right now since we know that these are like terms. 5n's minus 1n gives me 4n's. And I know that a 2 minus 6 gives me a -4. And because those are not like terms, you cannot combine them any further. All right, let's scroll down really quick here and take a look at our last problem. You have 6y minus 3 times the difference of x and 2y. The first thing that you should be able to recognize after yesterday's lesson is that this is the distributive property. And I know yesterday you used PEMDAS for that top portion. You said, hey, Miss Seiss, this works. That did work yesterday, and because you don't know today what these variables are worth or what they equal, you cannot combine those like terms. So let's just rewrite this using that distributive property. I get 6y minus 3 times x gives me 3x's minus 3 times 2y's gives me 6 total y's. Remember that when you are multiplying and dividing those variables, they can cancel out with division, and you multiply those numbers together for multiplication. Okay, taking a look then afterwards, let's simplify this expression. I have a y here, and just an x here. So I can really view this problem and rearrange it as 6y. And remember, this whole symbol, this symbol that's right in front of that 6y sticks with it. So I have minus 6y. And then remember, this symbol directly in front of there sticks with it. So minus 3x. Well, what is 6y's minus 6 more y's? That's going to leave me with 0 y's, right? So I really have 0 minus 3x. And in this case, I know that 0 minus 3x is just a negative 3x. Remember, that symbol that's directly in front of that term sticks with that term. Well, where did we mess up? We have 3x. Okay, well, that was your perfect example, right? We actually have 3 times a negative 2 here. This is where we messed up. So I really get 6y minus 3 times x minus 2y. Okay? So when I distribute, please, again, make sure I tell you all the time, and then here I made the same mistake. So let me be your lesson that you need to make sure 6y, a negative 3 times a positive x gives you a negative 3x. A negative 3 times a positive, a negative to a negative times a negative gives me a positive 6y. Okay? That is where we messed up. So I really can arrange this 6y plus 6y minus 3x. These two are like terms, so I know I can combine them. I get 6 plus 6 gives me 12 total y's minus 3x. Great, I'm glad we caught our mistake. So don't make that same mistake that I made there. All right, on the last slide, it says you have some money in a savings account and your sister has $25 more than you have in her account. You write an expression in simplest form. So our job is to write an expression in simplest form that represents the total amount of money in both accounts. Well, total amount of money means that we are adding. So I have the amount of the money that I have plus the amount of my sister's money. So in variables, here is the amount of money we have. We don't know how much money we have, so we're going to let that represent x. Then x plus 25 is the amount that my sister has, because she has what I have, and then she has $25 more than that. So my expression here is x plus 25. Here you can see they used the associative property, so they took x plus 25, and they just rearranged it so that way they added those like terms together. So x, remember, x plus x is 1 x's plus another 1 x's plus 25, which is going to give me 2 total x's plus 25. That is the simplest form that can be in because we've combined all of our like terms so far.